evening. Uh, you are welcome. Today will be the first lecture on data science, geographic data science. So I will be introducing the course today, what the course entails, and I think by my estimate, it may likely take us like 12 weeks if we want to really cover, although it may take us more than that, but I'm just estimating that. So it will include some practical, and it has to do with programming majorly. So I think the first thing in this course is the Geodata Revolution, and Geo with data science now. There are a lot of revolutions taking place in the geospatial space now, and it has to do with data, the interpretations of data, the how to get meaning from data, because data itself is meaningless, as we will see in this course, until we do some analysis on it. We have some, from when we do analysis on it, then we get an information. From the information we get knowledge, and from knowledge we can take some action on that data. So those are the things we'll be looking at. What is data science itself? What is geodata science when we have geo to it? So where can we apply all this into our day-to-day life? So those are the things we are going to be considering in this course. So this course or this lecture, I have a question just to say, okay, have you ever used data to make decisions in your life? So it's a question. And have you ever heard the term data science? And have you ever written a line of computer code just to solve some problem? These are the three basic things these courses will be answering. We'll be using data to make a decision, using all the techniques in data science, and implementing all these things using the computer code, especially Python programming language. So the course is more than statistics, more than a GIS course, and it's just a combination of both statistics and GIS in having a better preview of the course. So let me move forward. The philosophy behind the course is just that there are a lot of methods and techniques out there, which when we apply it on data, it gives us a general overview and intuition into the data. Just a very little mathematics. From there, we get a lot of information. So there are a lot of ways to continue on your own. After the course, you can make more research. I'm still making research, and even after the course, I can share some of my own portfolio with you, so that we know how we can really utilize this course. As I said, it will really take us a lot of weeks to complete, but at the end of the day, we will all appreciate the course. The course is Then I will be sending the slide or the website where you can find all the resources. It's an open source resources, so including all the lab we are going to do. So from there, we develop our own, customized for our own use. We we are good to go. So let me just leave all this. Let me go to the content. I think the big picture, maybe for the first 1 or 3 weeks, we can look at the big picture of the lectures on introduction of computational tools that we are going to be using. So then 4th to 9th, we meet of the course. A lot of concepts will be packed in that week. We may not follow this way just from the course. So let me move forward. Now, let me go to Geodata Revolution. Like I said earlier, this is an exciting time for geographers or geospatial analysts or anybody who have to do with who are one of things to do with geographic data. This is an exciting time because a lot of world application is waiting for this application to come up. Applying data science. In fact, a lot of company needs data that has to be related to the hard surface. So in this course, we have a geographer, we have a map fans, and we have data fans from people who really want to have data of any kind of interest. So, and the world itself is a data feed. It now depends on which data do you want. How will you get it? When you get those data, how will you process it to get an information? So these are the things we are going to be looking at in this course. So there is a term called datafication. So what does this term mean? It's a quantification of phenomena through the systematic recording of data and taking all aspects of life and turning them into data. So any aspect of life you could imagine can be turned to data for a proper analysis. So example, credit transaction, public transit, like transportation, tweets, Facebook, likes, Spotify, songs, and all that. So you can get some data from tweets because most tweets comes with locational data. So these are the things we are going to be considering in this course. I'm presently developing one bot on on Telegram that people can use to submit data. I will still share that one later during the course. So when you get those data, how do you make sense from them so that we can really make a decision? So those are the things we are going to be looking at. So many implications. We have window into human behavior. So data is a window into human behavior, and we have opportunity for optimization of systems. So when we have a better data now, there are resources that are available nowadays that can make us get better information from the data. There are many optimization techniques which we are going to be learning to make us get beautiful information from data. So although there are some challenges like privacy issue that people will not want to release their data, but for a reasonable government, they're supposed to have this type of department that can actually derive better information from various varieties of data. So these are the things we are going to be looking at. So why now? Why are we to study this thing now? The reason why we have to study this now is that we now have a lot of computing powers and storage. Even if your system is having a low CPU stuff, now you can do a lot of analysis online without computing. This class I intended to that we will be using Codelab. That's Google Colaboratory. And I will introduce us to it, how we use it for analysis, even if our system cannot really take, because most of the system that can really do this analysis has to have a graphics card in place. So, but now we can connect to cloud servers and do some analysis with it. So those are the things we are going to be looking at. So we have all the features available to do our analysis, to run model, to simulate data. Then there is better connectivity these days, with even the event of 5G that is coming, we can have a better connectivity. And geospatial technology in itself is advancing every day. A lot of tools to grab data, to extract data are now being developed. You see, in any aspect, you see, even in hydrography, in area photography, we have a lot of equipment now that can extract, that can be used to capture your data and process it once and for all with 95% accuracy. So with all this, I think data revolution has come to place. So we want to look at the confluence of the three aspects that I just mentioned. That's the computing, communication, and the geospatial, in creating large amount of data. Now, data itself is not very valuable. If you have data scattered all around, it's not very valuable until you subject that data to analysis. Then you get what we call information. So when you look at the information, you get knowledge about your data. When you have that knowledge, what next is to take an action on the data. And these are the benefits. These are the reason why we have to go into this course. Now, data science itself is a course on its own space, and a lot of people have started using it. In fact, if you shop online mostly, you will discover that these are the example I will still be raising later on. You discover that everything now in life is based on data science, and it is another revolution on its own. So in data science, we use methods, tools, techniques to turn data into actionable knowledge. Just as I said earlier, that from data, when you put in analysis on it, you get information. When you look at that information, to study that information, you get knowledge. And from the knowledge you have to take an action. So the method and tools and techniques to turn data into an actionable knowledge is data science. So it comprises of statistics, and if it is statistics, we need computational tools like programming to actually achieve this, because human being cannot really be doing all these statistics. Once you have an error, you start all over again. So computer can handle this for us in a better way. So another thing we need in this course is a better communication skill, storytelling, how you can analyze to tell people about the information you get from your data in such a way that they will understand what is actually going on. So domain expertise also. That's theory, why the data are the way they are. These are the things we'll be looking at for this course. So let's look at some example. If you have shopped in Amazon before, or you shop with Jumia or Konga, you will discover that the suggestion they will be giving you anytime you log into their website are products related to your past purchase on that website or your past view of products. They will just be giving you such suggestion. Even if you are the type that use YouTube very well, YouTube will be giving you suggestion of videos relating to your interest. How do they come about this? Is data science. They analyze your data. They know where you are going. They know the category of things you want. So if you are the type that are listening to music, the first thing they will suggest to you is music on YouTube. So the same thing. So many businesses employ data science now to boost their business. So that is on data science on its own. So another one is Aquascript, which we can also research on. So now our own main concern is geodata science. And what is this geodata science? It's simply geographic data science. It's a very large portion of all these new data that are inherently geographic or can be traced back to some location over space. So we want to be doing a study on data that can be geographically located. So that is the main goal of this course. It's not just ordinary data. We want data that has geographic inputs. That we can say, oh, this event happened here. It happened here, and we can do some analysis on that. So let's move forward. We can have an example like Uber. These are companies that make use of geospatial data science in their businesses. Now, I think maybe today, let me quickly introduce us to Codelab, because we'll be using Jupyter Lab for our programming, and that's the tool we majorly be using. And once you prepare your notes for analysis, you can run it anytime, anything you want to do it. So that is that. Let me quickly go to my Codelab. So you can also search on Google for Colaboratory. It's a cloud computing platform for programming language, for Python programming language, where you can write a notebook. You can write your code, run it, see how it runs, import your data, analyze it. So as you can see, it has RAM and disk allocated for you. So you don't need to have a better RAM on your system to run this. It's run on the cloud. Once you have a good internet connection, you get your feedback. So, and you can save, once you have a code, you can save it. So if you have a Gmail account, just search and it will give you an account automatically. I'm in my own account right now. So this Codelab is majorly for machine learning, and machine learning has to do with data science also. So as you can see, they say Codelab can just be called Colab for short, and allow you to write and execute Python in your browser with zero configuration, free access to GPU, that's graphics processing unit, and easy sharing. You can share it with your friend easily. So these are the things we are going to be using. But as we go further and advance in this course, we start using another tool called Docker to package our programs and other things. But before then, we have to learn the basic of Python programming, and that will be the main focus for the next 3 or 4 weeks. Now, basics of Python programming, then how we can apply it. We move gradually like that. So, you can read more about this. You go, if you have any to see, you can display your analysis data, the charts easily on Codelab. So that is what this class is just for introduction today. I don't know. Before I continue, if there's any question. Is there any question? Is there any question? We have 9 minutes more.
Yeah, okay. When we log, like, how long do we still need time when we are log out?
Hello?
Yeah, did you get me? I said we have like 10 minutes more now. When we are log out, do we still need to like log in?
No. I can end the class like this today. So by next week, we continue with our lab.
It's fine. Yeah.
So we start. This is just an introduction today.
Yeah, I think I'll just add and encourage. I just finished a conference last week, RSP. So, the problem is we have the data science, and we have the who do not understand geographic data, and we have the GIS guy who do not also understand the data science or the coding aspect. So there is a gap, and if one can fill in this gap, someone coming from spatial science, grasping data science, it will be a huge advantage. So I want to encourage us to like take this because very, very serious. There is a huge gap because we are in geospatial. So if we have this, that is a plus. I think David want to ask a question. David? Yep.
Yeah, briefly, just to add to what you just said, sir. Truly, there is a gap because recently, in fact, this year I've encountered so many people who are GIS experts, geographers, and they have issues doing this projection and also integrating some of these spatial attributes into what they are supposed to do. So sometimes they want to need a surveyor,
Yeah.
Learn this, it will help. Has really put. So thank you very much, sir.
Okay, thanks so much. Yeah, so just continue. Thank you.
Okay. I think we still have some time. So let me just start. If you look at the colaboratory now, there's a place called code where you can just start your code. If you look up here, we have some menu there where you, just like using an application on your desktop, you can create a notebook, a new notebook. You can open a notebook. Maybe you have a notebook on your system, and you can upload a notebook. Now, you can open a notebook if you have it stored on your drive in the cloud, or you can upload if you have it on your local system. So what is this notebook? Notebook is just a set of instructions that can be executed sequentially for your analysis. If you want, maybe you want to import some data, you just write a code import so you can view. One of the advantage of this notebook is that you can quickly view your data. you can quickly plot your data and see how it look before you even start any analysis. So those are the things we are going to be doing. Let me open a new notebook. Let me just do a little, at least for any programming language, you can print a sentence out. Just say print hello world. Hello world. So once you write your code finish like this, just if you click on this play button, you see the result of the code. If there's error, it will tell you, maybe you missed something. See, it is processing for me. And once the answer is up, you see now, I have an answer. Like this now, I can save this notebook and give it to someone who can see. So if I have a set of instructions like that, you will see it all like that. So let me say I still want to add some sets of code. If I click on this button, insert code, it will give me another block of code for me to exercise, write my code. So now, let's say I just want to, this is just an introduction that we have to go to variable, what variable is, data type, later on by next week by God grace, and that we give the lab note out for it so that we can also practice. It's also, the lab note is just like a notebook that we are working with. So at the end of the course also I can share the notebook we work on so that we can also do it on our own. Very easy, just to have an internet connection. Well, you are good to go. So let me see a code that I can write here. Let me go to, let me have a variable called first name. First name. Variable is just like a allocation, space allocation for data. So my first name is Omoware. So, and I want to have my last name also. So all in small letter, last name. So let me say last name is Bolarinwa. So I want to concatenate this in a string that he will be able to print this for me. So I can say print, or allocate these two also to another variable called name. Let me put these two together, a variable called name, where we have a string dot format. Still look at this later. So I want it to format the first one. I want it to format something for me here. Space. So the first value I want it to input there is the first name. Then, comma, I want it to give me my last name also. Last name. Don't forget, I've declared that variable up here. So computer will not complain that it doesn't know what first name and last name is. So with this, I've formatted my name in a way that is readable. So let me print it out and see if I have any error. Print name. Sorry, I have a typo error there. Print name. Then let me click on this and see the result. You see now, I have a better result now. You can now print my name as Omowari Bolarinwa. So in later on, we'll be looking at in details. This is just a sample of how a notebook could be. So what I've just done now is just to format a string, which is something we'll be doing a lot in geographic data science, especially when you have a shapefile, you want to do some kind of analysis, restructuring of your data and do some analysis on it. So we'll be doing that a lot. So less than a minute. So we meet next week. I will share this. Before we go, you can save your notebook with a name, maybe just an introduction, so that it can be saved on your drive. Intro. So we meet next week by God grace.